Hey everybody, welcome to chapter 18. So we're just now starting the cardiovascular system. This is oftentimes one of the most popular organ systems. And so we're going to talk about blood in this chapter. Whoa, okay, I don't know what just happened. That was weird. We're going to talk about blood in this chapter. Chapter 18 is all about blood. Chapter 19 is about the heart. And then chapter 20 is about the blood vessels. So we'll talk about blood, blood vessels, and the heart probably in all of the chapters a little bit, but we're going to focus on our blood in this chapter, okay? And so I love this picture. This is from your textbook. This is a figure showing a single drop of blood, and you can see, well, within that single drop, you can see a beautiful red blood cell here. You can see a white blood cell here, and you can see platelets right there. So this is using a scanning electron micrograph. So that's a very nice picture. Blood is considered a fluid connective tissue. There are two components to blood. We have the living component, which are the cells, and then we have non-living component, which is the plasma, which is what the blood is found in. So blood has a lot of different functions. It functions in transportation. So this is actually a figure from chapter 20. I told you I was going to have probably a little bit of each chapter within the other chapters, but so this is from chapter 20. And you can see the blood vessels. These are all arteries moving that blood flows through. So these blood vessels are kind of like roadways, and blood is kind of like the taxis in a sense. So they are so blood transports materials. Specifically, red blood cells carry oxygen and carbon dioxide. So oxygen is taken to our cells, and carbon dioxide, a waste product, is taken to our lungs. We also transport nutrients, like food nutrients. We transport hormones, which you heard about in chapter 17. We transport heat to the surface of our body. We transport heat to warm our body. Blood functions in protection. So this is a cartoon that I just think is adorable. Here we have all these red blood cells. Oh my gosh, oh my gosh. And there's a big white blood cell protecting from this ugly virus or bacteria, whatever you want to call it. So blood functions in protections. We have white blood cells, leukocytes, that protect the body. Some are non-specific protectors and some are specific protectors, which we'll talk about when we get into the lymphatic and immune system. We also have platelets. Platelets are small pieces of a larger cell called a megakaryocyte. Platelets aggregate together and protect from blood loss. So when you have damage to a blood vessel, platelets will aggregate at that site and form the beginning of a blood clot. And so I just thought this was a really cute cartoon. Here are a bunch of different platelets. And here we have Harry, who is a platelet, yelling at everybody else to get away from them because he doesn't want everyone to be so close. The other platelets were starting to wonder if Harry had chosen the wrong career. Kind of cute, just a funny haha, but I like it. Blood functions in regulation of body temperature, regulation of body pH. So when the body starts to heat up, that heat is going to move through the blood vessels to the surface of our skin. If our body starts to get cold, the blood is going to pool at the center of the body so that the organs that keep us alive will stay warm. pH, so blood has a very specific pH between 7.35 and 7.45. And so we don't want our blood to change in pH that much. If our body pH changes too much, we'll either go into alkalosis or acidosis. So we have buffer systems built into our blood that help us to maintain body pH. This is a centrifuged tube. So a centrifuge is what we use. It's a machine that spins blood, and then it allows us to see the composition of blood. So the hematocrit can be identified using a centrifuge. And so a hematocrit is the percentage of red blood cells in blood. And so down here we have all of these red blood cells. A typical adult individual has about 45% red blood cells. So here it depends on if you're male or female, but anywhere between 37 and 47% for a female, 42 to 52 for a male. So we typically say about 45% is the average for red blood cells. So it's one of the most common cell types in our blood. Then we have up here about 55%, almost 55% of our blood when it's spun out is plasma. So this is the fluid water portion of blood. All of this contains the water, the any proteins that are dissolved in our blood, hormones, nutrients, as well as waste products. And then less than 1% of our blood right here is going to be what we call the buffy coat. Buffy coat is where the white blood cells and platelets fall in. So it's a very small amount. So what are some characteristics of blood? Blood, it is warmer than body temperature. So typical body temperature is about 98 degrees Celsius, or not Celsius, Fahrenheit, or 37 degrees Celsius. Blood is slightly warmer, so it can help to warm the body. The pH of blood is slightly alkaline, 7.35 to 7.45, so average of about 7.4. Blood is thicker than water, so it's more viscous. And the color of blood is determined by the amount of oxygen. So if you have a bright red color, that means that you have a lot of oxygen bound to the hemoglobin. If it's more of a dark red color, then it's going to be less oxygen is bound. So when people see their veins, those superficial veins, and they look like blue or green, people think that blood is blue until oxygen hits it. That's not actually true. Blood is always red. Human blood is always red. Alien blood, I don't know about, but human blood is always red. The veins have that coloration due to different pigments and how we see things. So what are some components found within blood? So like I said, we have the majority of our blood is that plasma. About 55% of our blood is plasma. And in that plasma, we have a lot of dissolved substances. About 45% of our blood is going to be the formed elements. Most of those formed elements are red blood cells, but we also have a lot of other white blood cells, and we have platelets. So over here, this is just a nice table from your textbook that shows what are some of the basic components of the plasma. So 92% is water, 7% is protein. I don't know why. I get why this is bigger. It makes that look like it should be, 92% should be the majority, but we have a lot of different types of plasma proteins and where they are produced from and their functions. And then down here you have formed elements. Talks about the different types of formed elements, granular or agranular, where are they produced, and again, functions, okay? The liver produces the majority of our plasma proteins. So in blood plasma, we have albumins, which are the most common plasma proteins. We have fibrinogens, which is an inactive protein that, when activated, forms the meshwork of a blood clot. We have the, oh, I can't think of them right now, the different protein factors for blood clotting. And all of these are produced by our liver. And then we have antibodies. Antibodies are not produced by the liver. Antibodies are produced by B lymphocytes. B lymphocytes are part of our immune system, which we'll talk about when we get into the lymphatic system, which I believe is chapter 21, okay? There we go. So one of the functions of the plasma proteins is to produce a colloid osmotic pressure. So colloid osmotic pressure is the pressure that proteins have preventing fluid from leaving the blood. So think about water likes to follow solutes. Water always moves from where there's less solutes to more solutes. So we always want to have equal amounts of water to solute ratios, right? That's osmosis. So osmotic pressure is pressure that forces water not to leave, or that keeps water from leaving. Colloid osmotic pressure is the pressure that those proteins have to keep fluids in. The main player in colloid osmotic pressure is albumin. Albumin produces a very high colloid osmotic pressure in our blood plasma, and this keeps blood from leaving so that we don't lose all of our fluid when we have diffusion occurring or when blood is being filtered. If our liver is not functioning properly, then we're not going to produce these proteins. And if we don't have as many proteins in our blood, that reduces our colloid osmotic pressure, and this can result in a loss of fluid from our blood. The fluid can then be retained in interstitial spaces, causing severe edema or ascites. And so here is what happens during starvation or protein deficiency because of the liver not functioning properly. So if you don't have, if you don't have enough proteins in your diet, then you're not going to be able to produce those plasma proteins. You have to have amino acids to be able to produce new proteins. So if you don't have amino acids, then you're not going to be able to produce proteins properly. And so starvation can lead to a deficiency in plasma proteins, and that leads to extreme edema. And so you can see that here. Actually, this is kind of, well, not kind of, this is really sad. What they're showing here is where the person pressed on this child's leg. There's so much swelling there that the fluid, when he pressed, his finger indentation stayed in. This happens when you are severely edemic. And so it actually happened with my son once when he was throwing up and having severe diarrhea. He was just like a 2-year-old baby, just a tiny little munchkin. Not quite 2, but close to 2. And so he was deficient in protein at the time because he was so sick. And he had been throwing up everything, so he was dehydrated, as well as he lost a lot of nutrients. And so you could see that same pitting in the skin. And so he ended up in the hospital for like 3 days, which was kind of sad. But I was with him the whole time, so it was all good. The other is due to protein deficiency because you can't produce those proteins, typically associated with liver disease. So cirrhosis of the liver is a serious damage to the liver, which the liver can't fix. Liver is one of our organs that can fix itself all the time. But if it is too damaged, I mean, if you have too much scar tissue, then you can't fix it. And so things like alcohol can damage the liver if you have too much alcohol. And so this is showing ascites of the of an individual due to cirrhosis of the liver. So ascites is when fluid pools in that abdominal cavity. And so it looks like this person has a very large abdomen. He's probably not near as heavy, and you can kind of see in the arms, his arms are very thin. This is all excess fluid because of the cirrhosis of the liver, which is causing him to have less plasma proteins, and so all that fluid is pooling in his abdominal cavity. Another disorder is Kwashiorkor's disease. Kwashiorkor's disease is a deficiency due to a deficiency in protein because there's no nutrients in the environment. And so when you're looking at some of the lesser developed countries where we have starvation occurring, some of the people that are very ill, this person, you can see that ascites here, so their abdominal cavity is filled with fluid due to not having any protein in their diet. So they are weaned off of breast milk, and breast milk has protein, and then they're fed cereal. Well, cereal has a lot of energy. It has, you know, it's good on carbs, but there's no protein in cereal. And because of that, they're not getting those amino acids to build other proteins like albumin or fibrinogen. I'm going to stop here because this is already 17 minutes, and we'll get into blood cell production or hemopoiesis in just a few minutes. Bye.